Hello friends, welcome to another refrigeration and HVAC mechanic red cell license exam prep practice questions. And today's topic is on voltage imbalance or voltage unbalance. We start with the definition of the voltage imbalance or unbalance. Voltage unbalance or imbalance is defined as the maximum deviation from the average of three-phase voltage or current divided by the average of the three-phase voltage or current. The voltage unbalance is expressed in percent. This definition is based on this reference here from NEMA, National Electrical Manufacturers Association of USA. Next point is to how to calculate voltage unbalance. So there's four easy steps to calculate voltage unbalance. Step 1 is to calculate the average of all the line voltages. Step 2 is to determine the maximum deviation from the average voltage. Step 3 is to divide the maximum voltage deviation by the average voltage. Step 4 is to multiply the result from step 3 by 100 to get the final result in percent. So this will be easier when we solve a sample problem. So here's the sample problem. The three-phase compressor of an air conditioning system has the following line voltages. Line 1 to line 2 is 217 volts. Line 2 to line 3 is 220 volts. Line 3 to line 1 is 215 volts. So we are required to calculate the voltage imbalance. Solution. So as in step number 1, it says to calculate the average of all the line voltages. So average voltage is, we add the three voltages and divided by 3. So these are the three voltages here: 217, 220, and 215. So we just add the three voltages given divided by 3, and we've got 217.33 volts as the average voltage. Step 2 is to determine the maximum deviation from the average voltage. So we need to find out the difference of the given voltages from the average one by one and determine which deviation is the maximum. So now we have three deviations here. Deviation 1 is 220 minus 217 being the average voltage as we calculated in the first step right there. So we just minus, deviation 1 is just minusing the 217.33 average voltage from 220, we got 2.67 volts. And this will be the maximum when we compare to the other two deviations. So deviation 2 is 217.33 minus 217 is equal to 0.33 volts. This is absolute value so that we don't have a negative value. And deviation 3 is 217.33 minus 215 is equal to 2.33 volts. So the highest deviation, the maximum deviation is 2.67 volts. So all we did is just determining the maximum difference. So for example, 217.33 being the average here, we subtract that from 217 and then to 220 and then to 215, and determining which one has the greatest deviation. So by determining the difference, we see that the maximum deviation is 2.67 volts, which is deviation 1, and that's our max. So once we determine the maximum deviation, it is now easier in step 3. So now step 3 is to divide the maximum voltage deviation by the average voltage. So voltage unbalance is equal to the maximum deviation divided by the average voltage, 2.67 divided by 217.33, and then we multiply that by 100, which is step 4. So then we get 2.67 divided by 217.33 times 100 is equal to 1.23%. Just to show you again, the maximum deviation is this, 2.67 volts, deviation 1, divided by the average voltage of 217.33, right there, times 100, and so we get 1.23%. Okay. And then there is a recommendation from NEMA saying that it's recommended that voltage unbalances at the motor terminals do not exceed 1%. Imbalances that exceed 1% require the rating of the motor and will void most manufacturers' warranties. That is the risk. It will void most manufacturers' warranties. So that's the reference figure 20-2 of NEMA MG1 2011. Okay, I hope you learned something. from this video about voltage imbalance, how to calculate it, what are the steps. If you have any comments, questions, please let me know and I will answer them the best that I can. Okay, that's it for this video. Cheers and have a good one.